Good afternoon, everyone. My name is David Oliva, and today I'll be going over the effects of static stretching and its impacts on the muscular performance of the human body. All right, so here's the overview of what I'll be going over with you today. All right, so for the background, as I was trying to pick my topic, something intrigued me, in which I noticed that each time where I was in school or for my job where I had to work out, I noticed we always had to stretch before and after a workout. And I always thought that this was a good way to, not pull a muscle or not hurt yourself or prevent something like that from happening. But as I began to do more college classes and study upon this thing, I read that stretching doesn't necessarily prevent injury. Actually, upcoming research has shown that static stretching, which is the type of stretching where you kind of move and you kind of just push your arm. See right here, I'm stretching my trapezius brachii. You kind of just do that to actually get the most out of that stretch. But overall, it has negative performance impacts on the athlete. And stretching intensity and how long you do the said stretching, whether dynamic or static, which in this case my research has been done on static stretching, examples to the right, actually, it does impact the performance of an athlete. And many coaches, trainers, athletes, exercise facilities promote pre and post workout stretching. And there's a common belief that stretching helps prevent injury during a workout. Now, here's my sales pitch, and here's what I want everyone to get out of this briefing, is that stretching hasn't been proven to aid and prevent injury. I couldn't find any solid evidence. There's one or two researchers that actually said that this is indeed the case, but the majority of researchers say this is not the case, way more than those who say stretching does help prevent injury. Ongoing research has shown insight that stretching actually hinders athletic performance. There's been systemic reviews upon this, and actually it correlates toward the fact that stretching actually will hinder muscular performance. So I want you all to think, when is stretching appropriate, and does the scientific community accept stretching as good or bad? And this is what I found from a study earlier. Typical muscle stretching protocol performed pre-exercise warm-ups do not produce clinically meaningful reductions in risk of exercise-related injury in Army recruits. And those are some folks that work out almost daily. So my research question was, what are the effects of static stretching upon exercise? Could it aid performance, hinder it, synergize it possibly, and why? Hypothesis. So with the research papers that we did, we had to do two hypotheses. One was the null. No effects can be seen when static stretching is conducted, and the alternative/research hypothesis. Static stretching conducted before exercise will have an impact on athletic performance. Dependent variable will be muscle strength. That's depending on the independent variable. And the independent variable is going to be static stretching, or I had two groups where one did static stretching for 60 seconds and one did no static stretching. So the method I decided to go with was the YMCA bench press test. And overall, the reason why I picked this one, because not only does it test endurance, it also tests strength, which is something I really needed to actually visualize and know when it came to the static stretching. So overall, the participants are going to be all male or female, preferably. You can mix it up, but overall, you kind of want to keep it the same gender. On top of that, you want to keep it the same age. Why? Because the mean and the standard deviation between these groups, you want to try to keep as closely as possible. You'll notice that certain athletes, depending on their age, it can have a heavy influence on their athletic performance and capability. The younger one is, the more athletic capable they are, the more their ability versus older athletes. And so the procedure for the YMCA bench press test is going to have barbells. You're essentially going to get a bar and 35 pounds for the female athletes. Or if you have all male, you can go with 80 pounds. And you're going to have a metronome. And this metronome is going to be set to 60 beats per minute. You want to make sure that your athlete can actually keep up with that and actually hear it for this test. And also you want a weightlifting bench. So overall, participants will begin exercise on a tempo of 60 beats per minute. Each sound will indicate movement up or down. 1, 2, 3, 4, 5, 6, and so on. And continue until exhaustion, or when a required cadence can no longer be maintained. And that's when they exhaust or muscle failure, or they can't simply push up anymore. You go ahead and terminate the test, go ahead and lift the bar up, and safely end the test at that point. And it's a test of absolute endurance and maximal strength in accordance with body, weight, and size. And this is good because it can be used for athletes who are very prone to working out, and those athletes who don't work out at all, which is great for my study because I wanted to keep it as unbiased as possible. Now, this is simply just to test the static the two groups of static stretching and non-static stretching, and overall, this is a great way to see its effects. And as you can see here, depending on which age group you pick, again, you want to keep the males anywhere from around the mid-20s, or if you can go by this chart, you may go ahead and do that. But overall, what we're really looking for is the mean and standard deviation and the statistical analysis of an ANOVA. And I'll go over that later in the briefing. But here you can see the different types of tests for the YMCA chart. All right, so the statistical testing that I decided to conduct was a two-way ANOVA. And the reason why I picked a two-way ANOVA because I have one dependent variable, which is going to be muscle strength. And I have two independent variables. With ANOVAs, you can actually pick more than one independent variable, I found out. I wanted to conduct a test in which the static stretching was held for 15, 30, 45, and 60 seconds. But in this case, I only had two independent variables of static stretching for 60 seconds and then no static stretching. I simply didn't have enough time, and I asked for some volunteers from my work, since I'm in the military, so I conducted this study by their own free will of what to do and to actually test them to see it's more a competition, if you will. And this way, this method, two-way ANOVA, as you can see from the pictures, I got two novas facing different ways, so two-way ANOVA. Funny. We'll test the research and null hypothesis for interaction between both of the two independent variables. As I said earlier, the null and the research hypothesis are there, in which the null, no effects can be seen with static stretching, and the research hypothesis, in which static stretching does have an impact, where it can be negative, positive on muscular performance. So here are my findings. As I number crunched all this stuff and put it all together, it was important for me to remain unbiased, because for me personally, I don't believe that stretching has any added benefit nor injury prevention, as the research I was conducting says. But either way, it's good to have a blind study because you don't want the participants to know what's going on. As I did my research, I noticed that the means were very, very similar. And the p-value is 0.64, in which the size of the null hypothesis, as in no effects of static stretching, can be observed, unfortunately for me. But that is the research, and the part of taking this course is to remain unbiased. Though there's slight influence of static stretching upon the final score of the YMCA bench press test, null hypothesis stands. So overall, as I kept doing more research as the class went on, I began to discover that ongoing statistical research shows that stretching does not aid in injury prevention. Also, stretching time and intensity, dynamic or static, negatively impacts performance. So in this case, as an athletic trainer or a coach or any of that sort, you kind of want to comprehend this as thinking that static stretching is it good or bad for the athlete. I found out that the intensity and the duration of static stretching before for an exercise bout has a negative correlation, which as the more time goes on, more positive, the effects of muscular performance would degrade, as in go negative. So there's a negative correlation there. Stretching can be beneficial depending on the sport, such as gymnastics or possibly even swimming or of that sort, in which you want that extra range of motion for your limbs, because that actually might aid in performance or your ultimate goal. But the main thing I want everyone to get out of this is that stretching does not aid or actually improve muscular performance. It actually has negative impacts. And the more you conduct it for longer periods of time and intensity, it actually has a negative correlation. So the conclusion that I came up with was stretching before any exercise bout will negatively affect exercise performance. And that concludes my briefing. Go Lancers!